Welcome to this Swagelok video. Today's topic is considerations in design for minimizing droop in a pressure-reducing regulator. The purpose of a pressure-reducing regulator is to reduce the pressure in the system while minimizing flow rate changes. Droop is defined as a decrease in outlet pressure as downstream flow increases. This flow curve illustrates droop. The vertical axis represents outlet pressure, with the horizontal axis representing downstream flow rate. Notice how the curve slopes downward as the flow increases. This is droop. Every regulator will exhibit some droop, but you can take steps to minimize it. You can achieve a flatter flow curve by choosing the right regulator configuration for your system. This leads to more consistent pressure downstream. The most common type of regulator is a spring-loaded regulator. In this design, a spring applies force on a sensing element, either a diaphragm or a piston, which moves the poppet closer to or away from the orifice, controlling the downstream pressure. In this configuration, the inlet pressure is a constant 30 bar or 435 psig. The regulator is set to 8 bar or 116 psig. There is no flow at this time, as the downstream valve is shut off. As the downstream valve is slowly opened, you will be able to hear the increase in flow. The outlet pressure starts at 8 bar or 116 psig, but drops to about 5.5 bar or 80 psig. This gradual drop in pressure is droop. The pressure drop looks like this when represented on a flow curve. Now we will improve droop by using a different type of regulator. This is a dome-loaded regulator. The load force in this type of regulator is controlled not by a spring, but by pressurized gas in the dome chamber. The gas flexes a diaphragm, which moves the poppet away from the orifice, controlling the downstream pressure. A pilot regulator is used to control the supply of gas to the dome chamber of the dome-loaded regulator. And an outlet loop relieves the gas from the dome chamber when the downstream pressure is too high. This keeps the pressure constant in a dome-loaded regulator. Let's see how it works. As before, the inlet pressure is a constant 30 bar or 435 psig. The regulator is set to 8 bar or 116 psig. There is no flow at this time as the downstream valve is shut off. As the downstream valve is slowly opened, you will be able to hear the increase in flow. The outlet pressure starts at 8 bar or 116 psig, but drops to about 6.5 bar or 95 psig, or a lower drop than the system using the spring-loaded regulator. The pressure drop looks like this when represented on a flow curve. While there was still droop, the flow curve is flatter than it was for the spring-loaded regulator system. Let's look at one more possible configuration. This time, we will add external feedback to the pilot regulator. We will accomplish that by connecting a tube from the downstream process line back to the pilot regulator. This will allow pressure changes to be detected, thus adjusting the gas supply to the dome of the main pressure regulator. Once again, the inlet is constant at 30 bar or 435 psig. The regulator is set at 8 bar or 116 psig. There is no flow at this time as the downstream valve is shut off. As the downstream valve is slowly opened, you will be able to hear the increase in flow. However, this time, as the flow increases, the outlet pressure drops only slightly to about 7.5 bar or 109 psig. The pressure drop looks like this when represented on a flow curve. While the regulator still exhibited droop, the flow curve is flatter than it was for the spring-loaded regulator and the first configuration using a dome-loaded regulator. All regulators will exhibit some droop. Depending on your system, droop may be acceptable. But when it is critical to keep the pressure constant as flow changes, the right regulator configuration can help. Refer to Swagelok.com and the product literature for additional information. Thank you for watching. We will continue to develop videos like this to help you get the job done. Get more information by watching our other videos or contacting your authorized sales and service center.